Okay, let's try some patterns on a coordinate plane. Now, the reason we would do a coordinate plane in algebra is because sometimes there's actually patterns of numbers, and a coordinate plane actually shows them very well. And so what you'll see here is I've actually graphed some points, and if you have certain kinds of patterns, you can actually form a straight line. And so we want to see how this expresses a pattern and then what that pattern is. And so the first thing I think we should do is let's go ahead and list the coordinates of all of our points. And so I'm going to start at the bottom left. The first point, I know the numbers on my graph are hard to read, but the spaces are actually easy to count. And so we should see that the first point on here is -6, -4. And so what I want you to do is then pause the video and look at the other points that I've graphed and try to list them all. When you're done, you can hit play again on the video and see if you've written the same ones as I have. Okay, so I hope you've tried that. We said the first point was -6, -4. The next point that's graphed is actually left 4 and down 2, so we should say -4, -2. And then if we were to keep going, we would get to -2, 0. And then we get to 0, +2, 2, 4. And the last one we have on here is 4, 6. And so there's a lot of different ways we could talk about the pattern we have. One of the ways you could talk about the pattern would be to say that every time we list our next point, the x-coordinate is 2 larger and the y-coordinate is 2 larger. Or you could talk about the relationship between x and y. Many of you probably noticed that the y-coordinate is always 2 greater than the x-coordinate. And that's going to be a very important way of talking about this later. And let's talk about what this means. We're actually going to write this as an equation that has x and y as variables in a minute. And so let's just say that, for example, what do the points mean? Well, we know that if x is 0, which is this one right here, we talk about this point 0, 2. In our pattern, in our equation, if x is 0, then y is 2. Or if x is 2, which is this next one, then y is 4. Or if x is -6, then y is -4. And you may have even used some words, possibly in science class, called independent and dependent variables. And what it means is x is what we would call the independent variable. It's the first number. And whatever it is determines what the next number is. So I'm sure you could probably guess, for example, that if I gave you a point and I said that x was 6, I bet you'd already have a pretty good idea what y was. You'd probably say if x is 6, y is 8. And in fact, if we go to our graph and we go to 6 and we go up to where it hits line, we actually see that 6, 8 does fall on our line. There's actually an infinite number of points that go on their line. In fact, any number, you can put any number for x, and if you add 2, you'll always get y, and you'll find that that point would also fall on this straight line. This is why graphs are so great at expressing patterns like this. So the y-coordinate is always 2 more than the x-coordinate. And so the question is, could we write an equation that tells how to always know what y is when x is? Now normally, since y is what we call the dependent variable, we write it first. So put y equals, and then I want you to try to think of an algebraic expression that could give us y. I want you to give me y in terms of x is another way to say that. If we had x, what do we do to x to get y? And what we do is we take x, we take the x-coordinate, and we add 2. And you'll notice on every one of these, if I changed x for the x-coordinate, we would get the y-coordinate. -6 plus 2 is -4. -4 plus 2 is -2. -2 plus 2 is 0. 0 plus 2 is 2. 2 plus 2 is 4. 4 plus 2 is 6. And 6 plus 2 is 8. And so this is the equation. What I'd like you to try to do is think of another pair of numbers that would satisfy this equation. You can pick any number you want to with x. And if you add 2, you should get y, and you should see if it fits on this graph. For example, you could do 1, 3, or you could do -1, 1. And sometimes my line's not drawn perfectly straight, but were my line drawn perfectly straight, every point you did would show up on this line. So this is how you can use a coordinate graph to talk about an equation that has two variables, both an x and a y, or just another way of saying you're talking about a pattern. There's even a name for this kind of pattern. It's called a function, and they're very beautiful to show on a coordinate graph.